Yeah, so for formation equation, you have to remember that uh, everything must start from the element in its state at, if you want the standard equation for formation, then its state at room temperature and pressure. So ethanol is a liquid at room temperature pressure. So this must be a liquid. This is a gas. This is gas or solid. This is a liquid as well. And this is solid. Now, the equations would be, this starts at carbon, hydrogen, oxygen. These are the elements you need in this state. So this is graphite, solid, this is gas, this is gas. Then nitrogen, which is N2, plus hydrogen, which is like this, both of them gases. Octane is carbon plus hydrogen. And lastly, we have hydrogen, we have sulfur, and we have oxygen.
Balance them.
Yeah, I'm going to, yeah. So this is gas, this is solid, and this is gas. All right, so now for formation equation, what you have to remember is that we must get 1 mole of that thing. So it doesn't matter what the thing is, we just need to make sure that we have 1 mole on the right side. So that means I need 2 carbon, and I have 6 hydrogen on the right, if you add all of them up. So 5 hydrogen and then 1 from OH. So that's 6 hydrogen, and I have 2 on the left side. So we will use fractions. So 6 divided by 2, that's a ratio you have. So 6 divided by 2 is 3. So I need 3 here. Similarly, I have 1 oxygen on the right and 2 on the left. So I will get the ratio half, 1 by 2. 1 on the right, 2 on the left. So 1 by 2. And it's balanced. For the next one, we have 1 nitrogen on the right, 2 on the left. So 1 over 2. 3 hydrogen on the right, 2 on the left. So 3 by 2. Now, you might be wondering that, wait a minute, where will we get 3 by 2 hydrogen molecules? Turns out we can't, but this doesn't have to be a molecule. It could be a mole of those things. So this is mole ratio. So we are saying that 1.5 or 3 by 2 moles of hydrogen make reacting with half mole of nitrogen makes ammonia. So while it's impossible to get half a molecule of nitrogen, we can easily get half a mole. So that's why these numbers make perfect mathematical and practical sense. In the next one, we have 8 carbons. So that's 8. And we have 18 on the right, 2 on the left. So 18 by 2, 9. And same goes for the next one. We have 4 on the left, 2 on the, 4 on the right and 2 on the left for oxygen. So this is 4 by 2, which is 2, and everything else is balanced. So these are standard equations for formation, and the enthalpy changes in these equations would be delta H formation of these compounds. Of course, in the first one, we'll say it is the delta H formation of ethanol, which is usually this way. Usually this way is how we write them. Next one is for ammonia. Next one is for, and you get the idea that for octane and all that. All right, now take these things. I'm going to write a few of them, like ethanol, octane, and maybe CH3Cl. Now, take this thing and burn it. In fact, leave this one out. Let's keep things simple for now. Yeah, so you have, yeah, carbon and hydrogen. Okay, write the equations for combustion of these things and standard equations for combustion. Go on. So we have to understand that combustion requires oxygen, plentiful oxygen. So we'll react all of these with oxygen gas, and they will produce, carbon will produce carbon dioxide, hydrogen will produce H2O. And that is the same product in the first two. Third one will give us just CO2, no hydrogens, no water. And last one will give us H2O. Now here's the thing. We have to consider that we will take only 1 mole of the compound we are burning for it to be standard equation, which means everything else must come in a way that it registers like that. All right. So that it makes sure that there is 1 mole on the left side. So I have, in the first equation, I have 2 carbons. So I'll get 2 carbon dioxide, 6 hydrogen. So that gives me 3 water, because 6 by 2, that's 3 to balance it out. And now I'll calculate how much oxygen I have on the right side. Now, most of you have studied in O levels from me. So you might remember that I told you that always balance oxygen at the end. And now you understand why. Because now we have to make sure that whatever oxygen we need, we have that. So I have 4 oxygen here. So this is 4 here because 2 times 2, and this is 3 here. So 4 plus 3, that gives me 7. So I have 7 oxygen on the right side. On the left side, I have 2 oxygen. So 7 by 2. And that's how I balance it out. There you go. Now let's look at the next one. I have 8 carbon. So I'll put 8 here. I have 18 hydrogen on the left side, but 2 on the right side. So 18 by 2, that is 9. By the way, this is combustion. Yeah, go on. Now I have 16 here. I have 9 here. So 16 plus 9 is 25. So 25 by 2 here for oxygen. Carbon dioxide is balanced. For this one, I need half of oxygen. And this is balanced. There you go. These are my equation for combustion of these things. Now here's the thing. What if I have this equation? And now I want to make, so this is carbon plus half oxygen makes CO. So that's an equation, and we want to figure out delta H of this thing. All right. Now we are on to practicing for Hess law. Now, what I can do is I can use the combustion analysis for this one. So do these things burn? Yeah. Carbon on the left side burns. Carbon monoxide on the right side burns. So I will use the combustion analysis for this. So I can burn carbon and I will get carbon dioxide. And notice that I did not write oxygen because I'll get as much oxygen as I want. Similarly, if I burn carbon monoxide, I get carbon dioxide as well. It's the same product. Now I have what we can call a Hess cycle. Now in this Hess cycle, what do I need? I need to figure out this delta H. Okay. What is this one? Let me call this delta H1 and this delta H2. Now, what is delta H1? It is delta H combustion of 1 mole of carbon monoxide. And what is delta H2? It is delta H combustion of 1 mole carbon. Okay. Now I pick my starting point and ending point. So let me say this is my starting point. And just to keep things simple, this is my ending point. So now I have a direct path here and I have an indirect path here. Now these values are pretty straightforward. This value, delta H combustion of carbon, I can just Google it. It will be given in the exam as well. This is minus 394 kilojoules per mole. And delta H combustion of carbon monoxide is also pretty straightforward. It is minus 283 kilojoules per mole. All right. So let's use the starting and ending point and use the Hess law. Hess law was the delta H of the direct path is the same as delta H of the indirect path. That is Hess law, right? And that is an extension of law of conservation of energy. So I can say that delta H of this reaction is equal to my delta H2, which is this one, which is delta H combustion of carbon, minus delta H combustion of carbon monoxide. Why am I subtracting it? Because if you notice over here, the blue arrow is downwards, but the green arrow, my path is opposite to my reaction. So that is why I put a negative sign there. So now I'll simply plug in the values. So minus 394. Notice that this minus is not the one that I put myself. The minus is included in the delta H of this thing. Minus 283. I get minus 394 plus 283. And that gives me my final value. This is going to be, yeah, 111. So I get minus 111 kilojoules per mole, which tells me that if I burn carbon to make carbon monoxide, the enthalpy change is minus 111 kilojoules per mole. Is this reaction less exothermic than burning carbon in plentiful oxygen? What do you think? It is, right? Because the value of burning carbon in plentiful oxygen is minus 394. But value of burning carbon in limited oxygen is just 1. All right. Let's do another example. Here's a question. Okay, so calculate the standard enthalpy of formation of methane from the following data. Okay, so I want to figure out the delta H formation. So let me write the equation. That's the thing. Step one should be that you form the equation. So my equation is, I want to make methane. What should be my equation for enthalpy of formation of methane?
Say carbon plus 2 moles of hydrogen gas.
Good, very good. So carbon solid, which is graphite. You can write graphite or you can just write solid. Both of them are fine. Should make this. And this is standard enthalpy change of formation of methane. All right. Now, let's look at the data that they've given. They've told us that combustion of carbon, combustion of hydrogen, combustion of methane. So they're technically asking us to draw a Hess cycle using the combustion equations. All right. So if I burn carbon, I get carbon dioxide. If I burn hydrogen, I get water. If I burn methane, I get carbon dioxide and water. And because I'm burning 2 moles of water, 2 moles of hydrogen here, I will get 2 moles of water here. Now, I did not write oxygen anywhere. Reason, 2 reasons actually. Number one, oxygen is plentiful. So it's technically not part of, it does not affect the amount of product or the reactant involved because oxygen is the substance in excess. Number two, the amount of oxygen used on the left side, like burning carbon and 2 moles of methane, 2 moles of hydrogen, is the same as the oxygen required on the right side, burning methane. So because both of those sides have the same amount of oxygen, I can just cancel it out from opposite side of the equation. It's like if I have an equation x minus 2 is equal to 4 minus 2, I can simply cancel this minus 2 out. It's basic algebra, right? So x equals to 4. Just like that, because I have the same amount of oxygen required on the left side as right side, I don't need to write it. So whenever you're drawing Hess cycle for combustion, you don't need to write oxygen. Okay, so here you go. This is balanced, yeah. So let's figure out, let's put the values in there. Now, look, judging by the values that they've given us, combustion of 1 mole of carbon is minus 393. Combustion of 1 mole of hydrogen is minus 286. So 2 times that would be 2 times minus 286. I'm just writing the value here. Similarly, for methane, it is minus 890. Now, I have to pick my starting point and I have to pick my ending point. So tell me, what should be my starting point? Can you guys hear her?
No, sir.
Okay, probably something wrong with your audio. Maybe try joining again. So let's start with this. Okay, so she's saying start with carbon. Okay, and let's pick anything as the ending point. Maybe pick this as the ending point. All right, so my direct path is this one, and my indirect path is this one. All right, so indirect, direct. All right, so let me just put the values in there. So according to my direct path, minus 393 plus 2 times minus 286 should equal the delta H formation of methane plus minus 890. All right, so this is a pretty straightforward equation that tells me the delta H formation of methane should equal minus 393 minus 2 times 286 plus 890. Put it all in a calculator and you get the value. Minus 393. Okay, so I'm getting minus 75. Is that okay? Is that what you guys are getting? The unit is kilojoules per mole. All right, let's try another question. And this time we'll try to draw a cycle using formation values. Okay, so here's a pretty standard equation. It is when you try to make nitric acid. So how do you make nitric acid? This is the equation. You take nitrogen dioxide gas, burn it by dissolving it in water. Yeah, I can hear you now. What were you saying? Do you still have a question? All right, so we want to figure out the delta H for this reaction now. And I'm going to use, instead of using combustion values, I'm going to use the delta H formation values. Okay, so for formation, obviously, I need to start with the elements. So on the right side, I have hydrogen, nitrogen, and oxygen, all three required. Let me balance them out. So I need 2 hydrogen. I need half of nitrogen. No, sorry, not half of. I have 4 moles of nitric acid. So that gives me 2 of hydrogen, 2 of nitrogen, and 4 times 3, 12. So this is 12 oxygen. So I need 6 oxygen molecules here. All right. So you have to consider the amount of nitric acid that you need. This is 4, so balance everything according to that. Now, interestingly, it is the same thing for the right side. You'll notice this. Because for the right side, to make nitrogen dioxide, you need 4 of nitrogen dioxide, means you need 4 nitrogen. You already have that. You need oxygen. You already have that. To make 2 moles of water, you need 2 moles of hydrogen. We have that, and we have oxygen required. So the equation will be balanced.
I don't understand how you make these arrows. Like, आपको कैसे पता है कि किस direction में बनानी
Oh,
है?
because I'm using formation values for all of them. That means I will start with the elements every time. For combustion, I always start with the thing I'm burning. And for formation, I always start with the elements.
Okay.
Okay. Yep. So I balanced them looking at the right side of the equation, nitric acid, because wahan par balance karna was easier. I just had 4 nitric acid to balance. On the left side, it's all a mess. But it will be the same regardless of which side I balance. All right, now I need to figure out the delta H formation of water. This is given to me. So I can just Google it. The delta H formation of water is minus 286, all values in kilojoules per mole. The delta H formation of nitrogen dioxide is 33 plus 33. And delta H formation of nitric acid is minus 173. All right, so I have all these values. This is minus 173, this is plus 33, and this is minus 286. All right, so we are done with drawing the cycle. Let's start by picking the direct and indirect paths. I would like to pick, so Vamik, would you like to pick the starting and ending point? Vamik, are you there? Okay, Vamik is there.
From HNO3.
All right, so let's start with HNO3. And where do we end?
On the left side of the equation.
Okay, so this is my ending point. This will be my direct path. This will be my indirect path. All right, so judging by Hess law, the delta H for direct path, which is delta HR negative, should equal the delta H of the indirect path. Now for the indirect path, I'll go opposite to minus 173. So I'll put minus 173. And this must be multiplied with 4 because I have 4 nitric acid. Okay. Similarly, I'm going in the same direction as 33 and I'm making 4 nitrogen dioxide. So I'll go plus 4 times 33. And I'm going in the same direction of minus 286 and I'm making 2 of water. So I'll do plus 2 times minus 286. So there you go. I have a pretty straightforward question here. Minus delta H of reaction is equal to 4 times 173 plus 4 times 33 minus 2 times 286. Jo bhi answer aayega, we'll simply take that one. So you guys get it now, how to draw the Hess cycle. So let's see. Let's try to do a question using whatever you have learned. Let's see aapse hota hai ki nahi hota. So here's a skill check for you. All right, so I have the data for formation. So I'm going to make a cycle that depends on formation. So I have the elements I need are carbon, sorry. So I need carbon, hydrogen, nitrogen, oxygen. Okay. The right side is easier to balance if you notice. Then I will just balance using this one. So I have 4 carbon dioxide, so I need 4 carbon. I have 12 water, so I need 12 hydrogen. I have 9 nitrogen, but that's what I need for. And oxygen, how much oxygen do I have? So 4 times 2, 8 here, 12 times 1, 12 here, so that's 20. So 20 divided by 2 that I have here, that gives me 10. So that's what I need. So 10 oxygen. So now my equation is balanced. And because I'm using formation cycle, I will start with the elements. So I'll start from the elements. To make carbon dioxide, I will make water, and nitrogen. I don't need to draw an arrow because it's an element itself. Similarly, I need to put the arrow for N2O4 formation. I need to put the arrow for this thing's formation, whatever this is. All right, so there you go, 4 arrows. And now let me put the values there. So this one, the left one is plus 53. This one is minus 20. This one is minus 394. This one is minus 288. And this is X. This is what I need to figure out. So I pick my starting point and ending point. Let me pick this as my starting point and this is my ending point. So this is my direct path and this is my indirect path. Okay. So now I'm going to put the values. So my direct path, which is X only, is equal to indirect path, that is minus 4 times 53. Why? Because I'm going opposite to the blue arrow of 53. Similarly, I'm going opposite to the blue arrow of minus 20. So I'll put minus 5 times minus 20. Okay. I'm going in the same direction as 394. So I'll put plus 4 times minus 394. I'm going in the same direction as minus 288. So plus 12 minus 288. No need to put a value for nitrogen again because delta H formation of any element is 0. Put it all in the calculator.
Sir, where did you get the 5 from?
5 from. All right. So I have 5 of this thing being made. Similarly, I have 4 of this thing being made, 4 of this thing being made, 12 of this thing being made.
Okay.
So these are the values of it. Yep. And I'm done.